Okay, so in front of me, I'm on the agent development kit documentation, and I've got the evaluation criteria, at least the evaluation criteria that the ADK offers in front of me. Pretty interesting stuff. Now, at a high level, you might ask, well, why would I care about evaluation criteria? Well, the goal here is to gain more assurance into your agentic system, at least the agentic system you built with the ADK. You could use, and in fact, you would use in certain spots, unit tests if you've got something that's functional or some mathematical relationship where the input and the output, or I should say, the output always follows the input, it's deterministic. That will work well. Having said that, to the extent that your agent or your agents use LLMs, then the output is much less predictable. It's probabilistic, it's stochastic. You could have a test suite or an evaluation suite, even run 10 times, you might get 10 different results. And so this is something that you actually have to fight with. That would be completely unacceptable in a test suite, unit tests, functional tests, and so forth. And evaluations, it's just the nature of the beast. So, what I'd like to do is to take a look at just a couple of these criteria. We'll pick two. And then one of them we're going to run and we'll use maybe a proxy, just like we did last week, a local HTTP proxy. And we can take a look at the requests and see what it's doing under the hood. Okay. So, as a first point of interest, let's look at response match score, which I'll highlight here. So, response match score, it is a criterion, which I should say these criterion, you could almost think of them as assertions in the XUnit world. Here, you could think of them as testing strategies. So this testing strategy does not use an LLM as a judge, which means if it's going to answer a question, it does not need to appeal to some model to know if it's right or wrong. It's much more, in fact, it's entirely algorithmic. So response match score uses what it calls the Rouge 1 algorithm. There are several different Rouge variants. Turns out you could reference Wikipedia if you're interested. But Rouge 1 is pretty simple. It tests what they call lexical overlap, which is a fancy way of saying it takes the left and right hand side, or the target and the source, and it chunks them into unigrams, right? It splits them up into words, and it wants to know, are the words on the left side more or less represented on the right? Okay, order doesn't matter. If I had the string foobar baz, the response match score would be pretty high. In fact, to be exact, it'd be 1 if you just reverse the string, right? Bar, foobar baz bar foo, right? High match there. Pretty interesting. And if you've got an output that is, even if it's coming from an LLM, in particular if it's coming from an LLM, if it is in a template or could be very nearly put in a template, such that you can have a high degree of, well, let's just say you can make really good predictions on the output, response match score, super useful. Okay. But to be fair, also similar to what you might find in a, what we would call like BDD, or if you're doing test driven development, an XUnit based test suite, you've got these sorts of assertions already available to you. So maybe that's not very interesting. But what is interesting is, or a little more interesting anyway, is the criterion directly below it, final response match V2, which admittedly is a little bit of a mouthful. This does use LLM as a judge, and its description is as follows. It's an LLM judge semantic match to the reference response. So this means you have some input and then you get some output, and then you make some claim about that output, but it's a description, right? It's not talking really about its structure, right? We're not talking like lexically what this thing is supposed to be, but semantically what it's supposed to be. Super interesting. And so it's today, this is what I'd like to dig into. Probably no live coding today. In fact, I know we won't, but I've got an agent already set up, and it's fairly contrived because of course it is, right? It's just a means to end. I just want to see what final response match v2 actually does. Okay, so we'll run that agent, and then we'll look at the output in a local proxy. We'll just see what requests it's making. What's it do? What prompts does it use? Is it very different from the other agent prompt? What gets injected and how reliable is it? Interesting. At least I think it's interesting. If you think it's interesting, sit tight because we are going to jump into this right now. So I'll switch over to my terminal, and the structure here is pretty straightforward. And in fact, you know what? Instead of before we look at the code, let's just run this thing. That's going to have a LLM session is worth 1,000 words. Okay, so I'm going to type the word. If I can, type the word foo. Okay, we got foo back, but this time in uppercase. How about bar? We get bar back, but in uppercase. I feel like I know what this is doing. So this is an echo bot, which if you saw it is in fact the name of the agent itself, gives a pretty decent clue about what it does. However, there's some extra functionality, and this is completely arbitrary, FYI. But if I type in car, instead of echoing car back, I get a joke. Why did the jalopy go to the doctor? Because it was always carifing. I don't know what that means, but this is a joke. So we've got two different types of output. One's very structured. This would be or I should say the structured output, pretty good candidate for response match. And then this other thing down here where we're giving it a token, we've got this unigram car, and then it responds with a joke. How would you know what tokens this was going to use ahead of time? You wouldn't. So instead, we would just more likely describe, hey, if we give it the input car, there's going to be a joke. So this is a pretty good indicator of this silly little agent that we have here. Let me control C this web server, and let's look at the agent itself. Okay. We look down here at the bottom. This is Python. We're instantiating a single agent. It's called EchoBot. Descriptions, that's an EchoBot. We're using Gemini 2.0 Flash, and we've got a very simple instruction. It's exactly what you think it would be. You're an EchoBot. The request will have a single word. You will repeat that back in uppercase per its echoey mandate. If the request has multiple words, we will repeat back only the first. If the word is car, however, you must respond with a short joke about a car, but never about a bicycle. And by the way, I had to append this by never about a bicycle, because half the time, otherwise, it would tell jokes about bicycles. Why, I don't know. It's just what's in its cold robotic heart, I suppose. But I got rid of that through a little bit of prompt crafting just to make this a little bit cleaner. And then we've got a few shot example. Foo should give us uppercase foo. Same with bar. We've got a multi-token example. It should just give us the first one. And then a car should return some joke about a car. This is pretty simple. If you played around with ADK, it's about as simple of an example as you could get. However, we want to evaluate this. So what does an evaluation look like? So you already know if this is Python, if we're going to write some unit tests, you would expect to have some Python files or dedicated test files that you'd run, and it would do its assertions and give you some sort of output at the end. Okay, same with Ruby or TypeScript, Go, almost any language you could think of. If we're going to run evaluations, you could do this with pure Python, but I think more often than not, you use JSON. Let's take a look at what these look like. I've already quite handily had a couple built out. So we got two files here. We've got a criteria file, and we've got the actual, what they call the eval set. Now, there's a lot of boilerplate here. Most of this you don't need to pay attention to, except two parts. One, our user input, the request. Single token, car. Single unigram, car. And then we have our response for the model, which is qualified as a final response. But in fact, there's only one response, and that is a description. we're not actually going to make a claim about what it's going to say, but just or I should say lexically about what it's going to produce. But instead, we have a statement about the semantics of the thing, a short joke about a car. So this could be just stripped down into 2 lines. Input car, output a short joke about a car. Now, as this would be incomplete without the criterion, right? We have to let it know what what it should be evaluating exactly. And here's where we select some of the available criterion. And we're going to collect or select final response match V2. This will return a score between 0 and 1. We get to set the threshold. This is arbitrary. Anything 5 and above or 0.5 and above is valid. We get to select our model. This is cool. ADK is model agnostic. So as far as I know, we could select some open source models here or even Claude. To make things simple, we'll have Gemini 2.0 Flash. Then finally, number of samples. How many times are we actually going to run this? This is fascinating. This is something you never see in your unit tests, or if you did, I think you consider it to be a pretty massive anti-pattern. Okay, so input, car, output, short joke about a car. We're going to use an LM as a judge via final response match V2. We've selected our model. We're going to run this 20 times. Let's run it. But, as they used to say in the days of infomercials, there is more. I have, just like I did last week, my handy local proxy. How does this work? Well, as an example, if I curl over here in the left-hand pane to Google, well, we get the response, but notice how it's logged over here. We can look at the request. We can look at the response. It's 301, okay? And we get the detail. Interesting. So I'm going to delete this, clear that out. And the idea is that we're going to run our evaluation, and then we're going to see what the output is. But because those are fundamentally, they're just HTTP requests, we can log them and look at them. And in this manner, we can start to know what goes into an eval, what prompts potentially are used in a final match V2. What's it look like? How reliable is it? And so forth. Let's give it a shot. We're going to run this with ADK eval, which I've already run before. If you want to look at this invocation, it's ADK eval. The name of the bot, which is our echo bot. The path to our eval set, which is car joke eval. And then the config to our criterion. I should say that I'm only interested right now in testing the car part, the part where we get a joke. Maybe later we'll show a test that we can use response match. But this is kind of the more interesting thing. It's using an LM as a judge. So let's stick with this for right now. I'm going to fire this off. Let's see what happens. It's thinking. It's going to make a decent number of requests. 20, in fact. And then maybe while this is running, we can make a claim or try to think about what we should expect to see when we go to the proxy. Now we know there's going to be the initial input to the agent. We're going to give it the string car. It's going to return a joke. So that's at least one call to the Vertex API. Then we should expect to see 20 more calls where we're still calling Gemini, but it's going to take the input and the output collectively, and it's going to make a judgment call. Was the output good with respect to what we were expecting? It's going to take a look at a joke in particular, and does this satisfy our desire to have some particular joke? That's exactly the line that we had in our, if I bring this back up again, echo bot car file set JSON. We'll use a star here. We should be receiving a short joke about a car. This is what's ultimately going to get plugged in. Okay, so let's move over the moment of truth. What do we see? Well, we see a call to the OAuth 2 service because, again, unlike AWS, GCP does not use HMAC keys, right? It doesn't have an ID and a secret. It uses OAuth. Locally, I'm running on my local laptop. So my user in my home directory has got a kind of tucked away a SQLite database that's got a refresh token in it. That gets used as part of this request, and we get a bearer token back, which is used in these subsequent requests. Okay, so let's look at the first request. Okay, it's exactly as we thought. We have the input text to car, and we've got down here our system instruction that says you're a bot. Let's look at the response. This is our joke. Why was the car so tired? Because it had a long drive. Okay. This is what we wanted it to. This is the first call to Vertex. Now these subsequent ones, there are in fact 20 here, we can see right, are not calls to get a joke back, but they are calls to judge this input and output. Let's take a look. And look at this. Look at this ginormous custom prompt. What's it say? You are an expert rater for an AI agent. The AI agent is going to call an API to answer the user query and generate API tool use code based for the choice of the API and API arguments, which is actually, I should say, not quite true. This doesn't use an API call, but that's baked into the prompt here. Is that interesting? I don't know. We'll see. But if we look at the very bottom, okay, we see, what do we see here? Below are the inputs. We have the user prompt, car. We have the agent response, which is the joke. We have a reference response, this comes directly from our eval set, which asks for a short joke about a car. Then there is a statement here, an edict on what the output structure should be. It says the answer should be JSON alone, which follows the JSON structure below. It should provide its reasoning. It should say whether it's valid or invalid, and it should answer with assertiveness. The LLM needs to answer with its chest. So far, so good. But this is a big old prompt. Let's look at the response. We can see what it returns. Reasoning. Okay, well, it says that it's valid. It says the model responded with a joke instead of tool use. The reference response also states the response should be a short joke. It says it's valid, like that one. But we've got 19 more calls. What happens? Uh-oh. Well, this says that it's invalid. The model provided a joke instead of an API, instead of using an API tool. It did not understand that the user prompt car was a command, not a question. The agent's response, and here I am kind of reading this back in kind of a shitty tone, which is me anthropomorphizing it. But regardless, this call to the judge, it says it failed it. Note that the prompt is really pretty large. It talks here about there should be API calls and it might use API tools and so forth. And so it got confused on that. Let's look at the subsequent ones. This one says it's valid. This one says it's valid. Valid again. Valid. Valid. I'm not really stopping here, but the reasoning is slightly different each time. Valid. Valid. I want to see if we get another invalid. Valid. Most of these look valid, pretty good. Oh, I didn't see that one there. Valid. Invalid. We got another valid. Invalid. Same reasoning as the first. The agent responded with a joke rather than utilizing any tool. It's a playful response instead of a direct answer to the question. So this is it, again, kind of choking on its own prompt. If you want it to return, I mean, you can kind of see here that at a glance, it's asking for formatting. It's asking how it should parse a particular score, what's acceptable, what's not acceptable, what it should do for the output, what it might do with regards to tools and so forth. There's a lot to take in, and sometimes it screws it up. Super fascinating and super interesting. Now, overall, this did pass, but just note the possibility that it might not. The reason, if I bring this back up again, car joke eval, the reason I wanted this num samples is because sometimes it fails entirely. I should say the reason num samples is so high is because 5 is not always good enough. Sometimes it always passes, or there's a unanimous decision on whether it's valid or not. Just as often there's not, and sometimes it fails entirely. So I've upped the num samples from 5, which is a default, to 20, just to get better performance out of this. Okay, let's try, and I just have one idea on how we might fix this. And I close that prematurely. So we know that this a short joke about a car gets plugged in to the overall prompt for our judge. We also know that sometimes those invalid calls were invalid because they believed that there was an API call that was supposed to happen that didn't happen. Let's add or try to add instruction here that says there's going to be no API call. There will be no API call because it is not necessary. There should only be a car joke in the output. Okay. So let's run this one more time. I'll clear these out from my proxy and just see if we get a slightly better hit rate. To be fair, we did pretty well, only 2 out of those 20. So 10% failed, 90% pass. That's pretty good. That's well within our threshold. But let's run this again and see if we can get all 20 to work. And we'll look at these as they come in, okay? Same thing as last time. We have to get a bearer token, and we have to get our joke. Why did the car get bad grades in school? It only knew how to accelerate. That makes no sense, but let's take a look. Okay, this says it is valid. And if I'll bring your attention down here to the text, the agent provided a car as requested, or car joke as requested. It is valid. Great. Let's look at the next one. No API call. The reference response expects a car joke and no API call. Valid. 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 Right? And look, and in fact, this is doing exactly what we wanted to. That sort of reference response has made its way into our reasoning. And mainly because it made its way into the prompt. If you look here at the bottom, it's exactly as we had prior, but now it's just letting it know gently, hey, no API call. Let's see if any of these failed. I hope they're all valid. So far, so good. Valid, 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 valid. These are all saying mostly the same thing. Valid, 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 and valid, all 20. So what do I think that the takeaway from this is first is that you probably behoove you to minimize where you can, and you can't always, minimize these, I hesitate to say minimize LLM usage, but that's exactly kind of what I'm saying. Minimize the parts of your system that are stochastic to the extent that you can. Otherwise, I think that's just a recipe for endless angst. So your input and output, your original output that you get from your agent, that's probabilistic. You're not really sure what you're going to get. Now, you can do some prompt crafting, prompt engineering, but you can't really guarantee that. And so to get greater insurance, what do? You have an eval set. Now, some of these criterion are deterministic, so they may fail to the extent that the original output is stochastic, but a lot of these need to be judged with a rubric or judged semantically. And that's going to necessitate using more LLMs, which are, again, they're stochastic. They're probabilistic. These I've run this a couple of times now. Sometimes they almost entirely fail. Mostly they pass. Again, it's 50-50 on whether it's unanimous or not. But you can imagine that you've built out an agentic system, or you're an operations, you're in charge of keeping these things run smoothly. And for the past month, it's been working well. And then all of a sudden, your CI is failing because it's just decided that the judges, whereas the judge calls were previously they loved the output, now they don't. And so now you're going to have to go back and probably try to patch the prompt or do some prompt engineering, which is tricky. That doesn't sound super fun, but it's I guess it's the world that we live in. So again, to recap, I think that these are all incredibly powerful tools, but using something probabilistic on top of something probabilistic, on like these probabilistic turtles that go all the way down, is a recipe for, angst, quite a bit of it. So to that end, if you can simplify these systems, use to where you can things that are functional, things that are mathematical, things that are deterministic, I think the going will be a lot easier. You can imagine how you'd feel just overnight. You've changed nothing and now your project is poisoned. It's failing. You're not sure why. You update the prompt, but now other things are starting to fail. Or maybe they don't. Maybe they pass, they just start to fail a little bit later on. So for me, I think it's important where we can just to know what these tools are doing. We've seen final response match 2 on the wire. We know it's a prompt. We could potentially subclass some of these if we're in the Python world and try to update or simplify those prompts. Although I imagine that Google has taken pains to make these as high percentage as they can, but as we've seen, that's nothing's 100%. So with that, I will stop. Thanks for watching, and maybe next week we'll return to some live coding, or maybe we'll dig into some of these other ones. We can imagine they've got prompts all their own. We can see what they do. Talk to you soon.